In the SD-WAN overview and challenges sections, we really want to start to understand some of the different components, and particularly what is the need, what is the drive for SD-WAN. Now we think about kind of traditional networking. It was deployed when basically we had a very clearly defined security perimeter. Most applications out there were low bandwidth. Most contents resided in corporate data centers. But today, things are very, very different. High bandwidth, real-time, big data applications are really pushing the limits of what's going on within our network. In some cases, the majority of traffic is destined for the internet or for the public cloud, all right? And we have to take a look at how to handle these problems. As we move towards this cloud usage, in particular, software as a service, and with different applications like Microsoft Office 365, Google Apps, Box, and others. And so it's been very, very popular, but what is the effect? The number of devices are increasing, people are bringing their own different devices, and really, in a lot of cases, video has kind of become the new voice, where we had, all kinds of cool voice traffic for a long time, but now video is becoming the norm. And so we're seeing this go ahead and really give a lot of high bandwidth applications. And so we look at kind of these legacy networks and we look at some of the kind of the challenges there, all right? Part of it is going to be cost-based, because especially when we start having this traffic go over expensive MPLS links to go to internet locations or cloud locations that can eat up a lot of our bandwidth. Can get a lot of complexity here, where we have kind of this distributed control plane model, and every node has to be configured with specific routing and specific security rules, and it could take a while to deploy these networks, right? To get these networks up and running could take quite a bit of time. And so we wanted to come up with some better solutions. And so we start thinking about that. We're like, okay, well, how can we reduce, some of the cost and complexity here? And so we look at moving into this next generation of software-defined WAN networking. We need to take a look at today's cloud-enabled environments. Everything out there is becoming more and more cloud-based. We need to do things like pull out the management plane, the control plane, and the data plane separately so we can scale them. We want to go ahead and make sure that we provide flexible management solutions, whether it is cloud-hosted, which is generally what people lean towards, or if we have environments where they want to go ahead and deploy it on-premise. We need to support both of those. We want to be able to rapidly bring up new sites, and that's going to be one of the things that's really amazing with this product, is this idea of zero-touch provisioning, which we've talked about in Cisco for 20 years, is a reality. Those of you who have some Meraki background, you'll find a lot of similarities to this and how Meraki operates. We need to be able to go through and deploy applications rapidly, easily, and securely. And we'll see we have these per VPN deployments that we can do. Give us visibility. We need full visibility. We need to know what's going on in our network, all right? And we want this kind of single pane of glass for managing this. So there's a lot of different solutions out there. And when Cisco was looking at theirs, they had an internal solution, but they took a look at a company called Viptela. And we're going to see the reason they chose Viptela. There was a lot of different companies they could have acquired at that time. All right, and they looked at a bunch, but why did they choose them? We're going to see that it's really a powerful solution. It gives us great flexibility. We have cloud-based management. We have all different types of secure. All right, whether it's physical devices, virtual devices, we can do managed services. We have a very low CapEx and very flexible licensing. And it really is a great solution for most of these environments. So we're going to look at a few basics. We're going to start talking about, hey, what are some of the different components in this kind of the SD-WAN solution? Software-defined. When we say software-defined, we'll talk more detail about this. But one of the big components of software-defined is it separates out the control plane. And so instead of every device running separate routing configured protocols to get information, we want to centralize the control plane. We want to have flexibility in the data plane, not have the data plane limited by what is physically cabled, but we want to be able to logically determine what is cabled and separate out the management. And we'll look at each of these in detail. Most of the time, it's hosted out in the cloud, which makes it very easy. And part of what we want to be able to do is make decisions kind of past the layer 4. We're used to looking at, primarily, layer 2, 3, and 4 information. We look at VLANs, IP addresses, and port numbers. But what about those upper layers? 5, 6, 7, those upper layers. How can we be application aware, know the quality of the circuit, how good it's doing or how bad it's doing, and then give the ability to be able to scale up and have some flexibility. So we want to come up with some very cool solutions. And so we start looking at this. One of the things that we're finding is, many companies now have MPLS, and they primarily use an MPLS, and they use it for everything. But as we go ahead, and instead of, normally our MPLS tends to go back, back to our main headquarters. That's normally we do headquarters, then we go elsewhere. But as more and more connection options become available, broadband internet has become very popular. It's very inexpensive, and generally you can get, if you get business class broadband, it seems to have very good performance. LTE is great, especially for rural places or as a backup connection, right? It can be very inexpensive to use as a backup connection. We'll look at some of these, get some of that flexibility. We're like, hey, listen, we want to go ahead and support whatever topology. We're going to find that our SD-WAN solution doesn't care about what the underlying media is. As long as it can carry an IP packet, you can run this over frame relay, you can run over anything. We don't care. As long as my IP packet gets to the destination, that is what matters. So you want to be able to get that WAN cost down by being able to use less expensive WAN circuits. And we'll also take a look at doing direct internet access as another way to lower some of those costs. Now we start moving up. We start thinking about, layer 4 through 7, our firewalls, our load balancers, IPS. It can be very complicated to go ahead and get these things working. When I want traffic from point A going over to site D to go through a firewall, that can be very challenging to figure out, hey, how do we make this work? We're going to find that the traditional network is really designed for kind of optimizing connectivity between source and destination. And the services kind of just get inserted in the path, right? And so sometimes we need pretty complex policies to redirect that traffic to get to the appropriate destination. All right. And we oftentimes have to go through and do the securities. The second problem that some of these look at is there's kind of a trade-off between how long it takes to enable the application and the level of security. So when we start looking at the whole SD-WAN solutions, we wanted to do something simpler. We wanted to make it easier to be able to insert traffic into our environments. So we kind of start off this environment. We have somebody over here with a little bit of traffic. All right. They want to be able to send that. We want that traffic to hit the firewall, right, and get to the destination. All right. But wouldn't it be cool if instead of having to go all the way back to the headquarters, maybe we had a regional firewall? And so instead of sending that traffic all the way to the data center, it would go ahead and somehow figure out, hey, what's the nearest firewall that I can use? And actually go ahead and use the nearest firewall. All right. And so we can create very easy policies. These policies make it super easy. We don't use unnecessary bandwidth and gives us a lot of flexibility. We start thinking about our modern application-centric networking. We need to be able to not only look and say, hey, listen, I can identify an application not just on source port, destination port, but being able to do a deep packet inspection, to be able to do DPI, look into that packet and really know what is that particular traffic. And being able to not only go ahead and identify what these are, but create rules for that traffic and enforce service level agreements. Hey, listen, we want to make sure we're getting at least this quality of link. Maybe I can get to all three of these guys through, broadband, MPLS, LTE, but maybe one of these connections is currently having problems. Maybe the broadband's currently slow. Wouldn't it be cool if we could look at say, hey, listen, we want at least this level, maximum of this latency or latencies, and we can go ahead and really put up rules for the requirements for a particular application. We move to segmentation. Being able to isolate our traffic is going to be key to us. All right. We want to be able to securely separate out our traffic, whether it's within a company or with multiple tenants or for multiple reasons. We want to be able to isolate that traffic. One of the cool things we're going to be able to do is we're going to be able to go ahead and isolate traffic. We're going to be using separate VPNs. All right, that's how we're going to isolate traffic. And we'll see we can have over 500 different separate segmented networks or VPNs. The cool thing about this is instead of having to configure this device by device, we configure this centrally. It gives us end-to-end segmentation and really gives us a lot of flexibility in how we deploy. Now, this all sounds great for deploying on our network, but we connect to other networks. We connect to Amazon, we connect to Microsoft, we connect to ServiceNow, Office 365. We're going to find we have some really cool features. Wouldn't it be great if all of a sudden somehow out in the Amazon cloud, right? You're like, hey, we have Amazon, we have Azure. Wouldn't it be great if you can make that part of your network by installing one of these SD-WAN devices into that network? We're going to see how to do that later in class. Or wouldn't it be nice if we had some type of communication so we could actually know what is the actual performance of different circuits? If I have multiple paths to get somewhere, wouldn't it be great to know and have performance visibility to see exactly what's going on inside these different environments? So this is designed to make it very easy, right? We go ahead, easy orchestration, zero-touch provisioning, and things just work, right? Makes it very easy. All kinds of analytics, being able to do assurance, collecting data, generating reports. Now, I've worked at different companies, and sometimes we go from these scripts, we'll hire this super dude, that great programmer, he can write every script in the world, and he writes amazing scripts, and we are happy as can be because our network is rocking with his scripts, and then he leaves, and we become sad. Right? We want to make this easy for us to be able to get in this environment, be able to manage things, just click, click, being able to go ahead and have multi-tenant environment if needed. Sometimes tenants, multiple companies, sometimes different departments. All right. Being able to easily look at my global network and see what's going on. Right? I can see, okay, hey, listen, we're going to be talking about the control plane and our controllers. We're going to be learning about these controllers and what they're about. All right. We'll be talking about these, but being able to easily view or look at our entire network. And we're not limited at this kind of high-level view. We can drill down and get the itty-bitty details. I can see those key performance indicators, know what's going on, and really take a look and drill down. And, of course, I still have the CLI if I want to go down to that level. But you'll find that most of the things that you can do in the CLI, you can get from the GUI. Of course, from the GUI, we can actually open an equivalent of an SSH session over HTTP, and we'll see how that works a little bit later. So this is really cool. What we're looking for here is really to create a highly secure environment. First thing, remember, we don't care about the transport. I don't care whether it's broadband, MPLS, running over barbed wire, or whatever it is, as long as my IP packets get across. But part of this key is we're going to assume that we don't trust any of these fabrics. We want a zero trust environment that we have to go ahead and get that security to make sure we know we have a very secure environment. On top of this, we want to be able to offer numerous services. All right, we see some of the services here. We'll be going through these services in class and understanding them. And then on top of that, being able to take a look and do application policies. We're looking to have a complete full feature set that gives us that complete ability. And, a big part of this is going to be moving away from that traditional idea. In our traditional environment, right, when we start looking at this, like, okay, well, we've been doing this where I have lots of individual devices all over the place, right? Like, okay, well, that's nice. Now what happens? Well, hey, I need a management plane. Oh, yeah, SSH into this one. I'm using whatever to manage it. I need a control plane. I'm using OSPF to learn routes. I configure OSPF on this guy. And a data plane, or whatever encapsulation that one's using, I configure on that device. Okay, not bad for one device, but as you add more and more and more and more devices, it becomes unmanageable. What we want to do is take these things like the control plane and management plane and centralize them, simplify them so they work for us and work much better for us. And that's part of what we'll be trying to understand is how can we go ahead and simplify things so we're not configuring individual devices, we're configuring our network and our network infrastructure. And so we'll start looking at this. One of the terms you'll see is Secure Extensible Network, or SEN. All right, it's not used all the time, but I just kind of want you to know we're going to be learning about these different components, and some of these are going to be at the orchestration plane to help automate things. Some are going to be at the management plane, some are going to be at the control plane, and some are going to be at the data plane. We'll be going through detail about each of these objects and how they work, but you'll notice a few things happening here. The management plane and control plane are out in the cloud. And the data plane down there, we're going to see how that's going to be automated. Okay. Now this route here in the cloud, it doesn't have to be on the cloud. You can use Cisco Cloud. 90-some% of clients do. You do have the option to do on-premise or host it in another environment. So this is kind of what we'll be looking at in the next few sections. We can see we have challenges, and we're going to look at the solution that Cisco has to help us solve these problems.